This is an extremely compact redstone dice machine that I made, but how does it work? In this video, I will be explaining the inner workings of this machine. This video does not include a tutorial. If that's what you would like to see, then you can go check out the video linked in the description after this one. The machine is made of two main parts, and the first one that I will explain is the Shulker Box Randomizer. This part is responsible for generating the random number itself by utilizing a property of dispensers. When dispensers are activated, they will choose randomly from the items inside, so we can take advantage of this by placing 6 shulker boxes, each with a different number of items inside. When the dispenser is activated, a redstone comparator reads its contents and outputs a random signal strength. And this is the final design of the randomizer that I used in the build. As you can see, this is the input button, and when you press it, it will activate this redstone line, powering the copper bulb and making it toggle its state, and also makes the comparator reading the copper bulb change its state as well. This triggers the observer, which gives a very short pulse to the piston. The piston breaks the old shulker box, which drops as an item and goes through the hopper back into the dispenser. Meanwhile, the signal from the button gets delayed by these two repeaters before activating the dispenser, which gives just enough time for the shulker box to end up back in the dispenser. This ensures that the random number generated is truly random. The second and last component of this machine is the display. For the display, I decided to go with a segmented display, which is basically just a display with parts which can turn on and off independently of each other. This is similar to the display of a digital clock, which also uses a segmented display. However, it uses 7 segments to display each digit, while the dice machine's display is simpler and only has 4 segments. It's important to note that some of these dots are connected. For example, the yellow dots labeled as segment 2 have to both be on or both be off at the same time, because they are connected and are part of the same segment. And as you can see, with just these 4 segments, we can display any number from 1 to 6 like the dots on a die. Looking at this table of which segments turn on for what number, you might notice some patterns. For example, segment number 1 only turns on for odd numbers, and segment number 2 only turns on for the number 6. Segment number 3 only turns on for numbers more than or equal to 2. And finally, segment number 4 only turns on for numbers more than or equal to 4. Detecting if the number, which is represented by signal strength, is equal to or more than a certain amount is very simple. For example, to detect if the signal strength is more than or equal to 2, just look at the second piece of redstone dust. If the number is 1, the signal will not reach it and it will be off. But if the number is 2, this redstone dust will be on, and if the number is more than 2, then it will still be on. Detecting if the number is odd is a little bit harder though. Because there are only 3 possible odd numbers, 1, 3, and 5, we can say the signal strength is odd if it's either of those numbers. But how do we detect, let's say, if the signal strength is exactly 3? Well, I used some logic gates implemented in redstone to do these checks. 1. The third redstone dust must be on, and 2. The fourth redstone dust must be off. By checking these 2 things, we can check if the signal strength is exactly 3. And by copying these logic gates to the respective dusts for 1 and 5, we complete the odd number detection circuit. And that's all of the logic used in the machine. Now, all we need to do is to wire the outputs from the logic circuit to the pixels of the screen. This was not that hard to do, but it was quite tough to fit everything inside of the small footprint. Here you can see a compilation of how each of the segments was wired on the screen. By the way, while making this video, I discovered another similar design that is also very compact, made by MyZuma Games and later updated by Mazi Crafter. So I will leave the link to those videos in the description if you would like to check it out. And that's it for the explanation. Before building this machine, I definitely did not expect the final design to be this small, so I'm quite happy about that. I hope this explanation gives you an insight into how this machine works. Make sure to check out the tutorial video if you're interested in building it, and thanks for watching.